If you're planning to perform any AI training, you'll likely be familiar with Jupyter Notebooks. Setting up a notebook is straightforward in our AI studio. Select a region that's most convenient and accessible for you. Give your notebook a name. Choose whether to reserve GPU resources for consistent availability or opt for an elastic notebook, which allows you to dynamically allocate GPU power only when needed. This elastic option helps minimize costs while you're writing code, with charges only applying when you run the GPU-intensive tasks. For now, let's go with a reserved GPU. This way you can select the number of GPUs you need. For the container image, you have a variety of options to choose from, depending on your needs. For instance, you can select pre-configured images like PyTorch or TensorFlow, which come with all the necessary libraries and dependencies pre-installed for deep learning tasks. Additionally, you can configure the volume to ensure your data remains persistent. Once everything is set, simply launch the notebook. Now we'll wait just a moment for the Jupyter Notebook to initialize, and it'll be ready for use in no time. Great, our notebook workspace is now up and running. Let's connect to the notebook workspace to start using it. This image comes preloaded with a PyTorch tutorial as an example. You can use this guide to fine-tune and train your own open-source large language models or proprietary models. The tutorial is designed to assist you in tailoring the model to your specific domain, making it a valuable resource for your training and fine-tuning needs. You'll notice sections here that detail the training steps, epochs, and loss, giving you full visibility into the training process. While you can explore these details at your own pace, we won't dive too deeply into them today. As we've explored the reserved notebook, let's now take a look at the elastic notebook. What makes the elastic notebook particularly useful is its cost efficiency. You can save the higher charges from using GPU instances like the H100 while you're simply writing or editing code. Instead, you can work on general compute resources without a GPU and only connect to a GPU kernel when you're ready to run your workloads that require GPU power. This flexible approach ensures you're only paying for GPU resources when you truly need them, making it a cost-effective solution for your AI development workflow. Let's say our code only requires general computing for now, so we'll use a CPU instance. However, when we're ready to switch to a GPU instance, we can simply connect to the appropriate kernel on the spot. For example, if we need to run some training, we can connect to the H100 GPU kernel seamlessly. To verify that the GPU is active and ready for use, we can run the NVIDIA SMI command. This will display the GPU details, confirming that we've successfully switched to the H100 instance. This approach allows you to dynamically switch between CPU and GPU resources based on your needs, making it a cost-effective and flexible way to use notebooks for AI development.